Like I said in our talk about framing plans and just framing of concrete buildings, is that the floor system, the beams, the columns, they're all monolithically cast. I mean, you'll have the beams that are literally framed. The concrete is poured. So it's all in one with the column. It's all in one with the floor slab, and so on and so forth. It doesn't have to be that way, but that's generally the way it works. So what I want to look at is just slabs for a minute. And there's two types of slabs. One type is called a two-way slab, and the other type is called a one-way slab. Now, when we talk about one-way and two-way, that's a structural term. Okay? You can talk about construction terms like flat plate or flat slab, and those are beam joist systems or joist pan systems and things like that. And that talks about an actual construction technique. But what we're talking about is a structural technique or structural type. And so we'll focus in on one-way slabs. One-way slabs are generally rectangular slabs. And that means that they're twice as long as they are wide, at least. Okay? So they're, when you look at the perimeter of how a slab is supported, it's generally going to take the shape of a rectangle. What a rectangular shape will be, or what it will do for us, is it's generally these slabs bend primarily in one direction. And since they bend in one direction, that direction, I should tell you, is the short direction. Since they carry moment, or they bend primarily in this one direction, the short direction, the reason we lump them in right here, with our discussion now, is they behave exactly like rectangular beams. Everything that we've talked about up to now, phi mn greater than or equal to mu, phi mn equal phi times t times the quantity d minus a over 2, all that stuff still holds true for one-way slabs. Okay? So a one-way slab is a rectangular slab. Again, in reality, this will be monolithically cast, just like we talked about the beams and columns being all monolithically cast. Being rectangular, and you put floor loads on a rectangular section of slab that's rectangularly supported, it'll bend in the short direction. Okay? And that's not, too much unlike, if you had a piece of paper, if you could imagine this, that was rectangularly shaped, and then you had supports on all four sides, and you put a load on this, how would it have a tendency to bend? Well, it'd bend like this, right? It's bending across the short direction. So it's almost like what we're talking about with a concrete slab. So everything holds true. All the formulas that we talked about previously, they all hold true. If I was going to design the steel in a one-way slab, I would design it exactly using the formulas that we talked about before. So it's essentially the same. There are two differences, I'd say, in a one-way slab. One-way slabs, even when you say, hey, it's bending like this, therefore I'm looking at the slab, do I design for the width of the slab being this long? The answer is, well, you could. Generally, you don't. Generally, when you look, you're doing a design or evaluation, you generally consider for a slab a 1 foot strip. that'll be your width. So, I mean, you know, you could look at a slab and you could say, hey, my slab's 20 feet wide. You know? I mean, the slab might only be 5 feet, might only have a span length of 5 feet, but the slab might be 20 feet wide. Well, should I evaluate it like it's 20 feet wide? Well, you could. There's nothing wrong with that. Your numbers probably get pretty big. What most people do is they say, well, this 1 foot strip from here to here is the same as this 1 foot strip from there to there. It's the same as this 1 foot strip from there to there. So most people will say, you know, even though you have this slab that's, you know, 20 feet wide by 5 feet long, let's just look at it like it's 1 foot wide. And then we'll design or evaluate it in this 1 foot strip, and all the other strips will be the same. Okay? So, 1 foot strip is typically going to be our width. Our width is typically 12 inches. The only other thing, because we do this, how are slabs reinforced? I mean, they're reinforced with steel. Okay, same steel. But what's the difference between a slab and a beam when you see the steel on a slab? Huh? Well, it could be reinforced with welded wire mesh, but we won't talk about that. Well, and it might use decking too, but again, we're just talking about the concrete. The steel's going to be given to you in a center-to-center spacing, right? I mean, have you ever seen a plan that says, you know, they don't, some plans might say, hey, we got 68 number 4 bars at 6 inches on center. But a lot of plans will just say, you know, you got number 4 bars at 6 inches on center. It's up to the rebar fabricator, the contractor, the estimator to figure out how many bars they actually need. Okay? So a lot of times you just have on-center spacings for rebar. So what I'm trying to get at, when you use this 1 foot strip and everything's talked about in 1 foot sort of a 1 foot sort of terminology, your area of steel then becomes so many square inches per foot. I mean, when these guys get out to the field, they're not setting these rebar saying, hey, I got to make sure I got 2.3 rebar in this 1 foot. And over here now, I got to my next foot, I'm going to be putting 2.3 rebar in here. Guys out there, just they come out and they say, hey, it's 6 inches on center. So let's get my chalk out, you know, away we go. You know, the 1 foot idea, the 1 foot concept is just our idea. But nonetheless, when we start evaluating or looking at area steel, since we are dealing with 1 foot, you know, the concept of 1 foot width, square inches that we deal with then for the steel are, for design purposes, per foot area of steel. Okay? But out in the field, it's not that way. You know, it's just a number 4 is 7.5 inches on center. Okay? So, anyway, does that make sense? Now, there are tables, typically, there are formulas that you can use to take a spacing, a bar and a spacing into a square, you know, area of steel per foot. The general formula, I mean, there's a couple of them, but if you want to say area of steel per foot, would be that. 12 times the area of the bar divided by the spacing of that bar. What's that?
I thought that was an R.
12.
Oh, wow, 12. Yeah, that's a 12. 12 area of bar. So for instance, if you had a number 4 bar, which the number 4 bar has an area of 0.2 square inches, you had a number 4 bar every 6 inches, it'd be 12 times 0.2 divided by 6. That would give you 0.4 square inches per foot. Okay. There are tables. Tables in the back of your book, tables that are going to be in other books and chapters that will have, again, all the bars and then just a variety of spaces and what this calculates out to be. So you can either remember this or you can go to tables. We have tables in our book or in our lessons, in our chapters that will help you out. Okay, so you can use that if you'd like. But that's a formula to calculate. Yes.
What is this?
That would be the spacing, the on-center spacing. Yes.
You take the 1 foot strip, wouldn't the moment be more in the middle and in the end?
Yeah, we're going to consider them to be simply supported. So yeah, we typically, I mean, it depends. Usually floor loadings are going to be uniform, but you know, so yeah. But I mean, still, we have to have this bar. You know, we have a, you know, if that's my slab. It's supported on all the edges. I'm looking at a strip that runs this way. So I'm acting like it's supported there and it's supported there.
It wouldn't be calculated, it wouldn't really be the same, the center to the end.
No, it'd be like a beam that's supported here and here, and you got a beam running between it. That slab is essentially a beam.
Would you typically run your rebar the short distance?
In a one-way slab, the short distance will have the bending steel in it. Okay. Now there is steel that runs the other way, probably too. But what's that steel running the other way for? Not compression, temperature and shrinkage. Okay? Go to our hallway out there. Hallway is long and narrow. Where do all the shrinkage cracks occur? Like this, right? So if we had bars running this way, that would help to catch it, wouldn't it? All right? So long, narrow, the shrinkage occurs in the long, narrow direction. I mean, probably it occurs in the other direction too, but primarily in that direction.
And do we design for that? One-way slab?
Yeah, actually you do. I mean, it's not, I wouldn't say it's designing for it, but there is a little formula that you use that the code would give you and say, hey, you should use this much temperature and shrinkage steel.